This is a JPSS quick brief on sea ice as computed by MIRS. My name is Scott Lindstrom and I'm showing material largely developed by Carl Dierking at GINA. Objectives for this training are shown here. Knowledge of sea ice concentration is valuable for shipping concerns, but also for weather prediction. Solid ice on water reduces sensible and latent heat fluxes, and that can affect the weather. MIRS, the Microwave Integrated Retrieval System, is designed to create consistent products regardless of input, whether it's the Advanced Technology Microwave Sensor, ATMS, on SUMI-NP and NOAA 20, or the Advanced Microwave Sounder Unit and Microwave Humidity Sensor on NOAA 18 and 19 and MEDOP, or the GMI on GPM or SSMIS on F17 and 18. The products created have different resolutions based on the instrument used, but should give consistent values from one instrument to the next. There's not a lot of energy being emitted from the Earth in the microwave. That's why microwave energy is detected on polar orbiting satellites that are much closer to the Earth, around 800 kilometers, than geostationary satellites around 36,000 kilometers. To sense microwave from a polar orbit, satellite dishes are a large but manageable size. That would not be the case from geostationary orbit. Ice versus water can be detected because of emissivity differences that are related to the molecular structure in liquid versus frozen water. Compare these two images, composites for one day, from infrared imagery on the right and microwave imagery on the left. There are many gaps related to cloud cover in the infrared data that do not appear in the microwave imagery. If you were to zoom in, you would probably see the significant horizontal resolution differences between the ATMS footprint and the MIRS infrared footprint. Detection of leads, for example, is difficult in microwave imagery. But microwave imagery gives you a consistent, reliable signal from day to day. This means it's far more useful for identification of trends, for example. This example shows how MIRS gives similar answers for MEDOP-B with AMSU-A and MHS, and for NOAA 20 with the ATMS. Click the link to show the website where the images originate. MIRS is designed so a consistent signal occurs regardless of differences in the microwave sensor. One thing that will differ, however, is the horizontal footprint. ATMS has a different footprint than AMSU and MHS, so the resolutions will differ. This imagery, processed by CSPP from the direct broadcast antenna in Fairbanks, shows sea ice concentration over the Bering Sea and Arctic Ocean, as well as visible snow ice imagery and infrared imagery. Clouds obscure the view of surface ice conditions in the visible, in the near-infrared, and in the infrared. But microwave imagery is relatively unaffected by clouds, and a useful signal is present even where clouds are present. MIRS is one way to detect sea ice. There are others that are enumerated on this slide. Microwave imagery has the benefit of producing a signal regardless of cloud cover. In a cloudy Arctic or Antarctic, that is important. But microwave resolution is typically poor, something like 10 to 15 kilometers at most. Infrared, visible, and near-infrared data, at 11.5, 0.64, and 1.61 micrometers, for example, have much better horizontal spatial resolution and can be used to detect ice, but it can be challenging to distinguish between ice and snow near the coast. And during the long polar night, visible and near-infrared data are limited. Synthetic aperture radar, SAR data, gives high-resolution information and, like microwave, is unaffected by clouds. Its coverage is extremely limited, however. Here's a summary of benefits of microwave on the left and limitations on the right. Because a signal is available daily, because cloud cover is not an issue, microwave data is most useful in identifying trends and anticipating short-term changes in ice pack. Click the link to find descriptions of the different microwave sensors on different polar orbiters. Mappings of MIRS microwave products are also available online at the link. Some are also available in real Earth. This concludes the quick brief on MIRS sea ice concentration. Thanks for listening.